Hi guys, welcome on the channel. So in this lecture we have a PYQ of JEE Advanced 2020 which is based on the rotational motion and the collision. So we'll go through this question and then we'll try to solve this question. If you want to try this question, just pause this video and try it by yourself. Think about the methods or the concepts which you will apply before solving this question. Okay, so let us go through this question. So we have been given that there is a rod of m mass and the length L is pivoted at its one of its end is hanging vertically. A bullet of same mass and moving with v speed strikes rod horizontally at a distance x. It's pivoted from its pivoted end, so as they have given in the diagram, and gets embedded in it. The combined system now rotates with angular speed omega and about the pivoted point. Then maximum angular velocity and it's achieved. Omega m is the maximum angular velocity which is achieved, and at x equals to xm. So then we just need to check out these correct options. Okay, all right, so it is hitting here and then it is getting embedded in this. So if it is getting embedded in this, so then we'll think about it. Can we apply the conservations? So if we look at the conservation of the linear momentum, we cannot apply the conservation of linear momentum. The reason is because linear momentum, there will be some external force acting on the system at pivoted point in the x direction, so that's why linear momentum is not going to be conserved. But what about the angular momentum? Angular momentum, will it be conserved? So yes, angular momentum about the pivoted point will be conserved, about this pivoted point. Why? Because if we just draw the system's FBD or otherwise the individual particles FBD just before collision, so we have like this, or during the collision, this is the bullet. Okay, this is the bullet, it is getting somewhere at the x distance, right? And at that moment there is some internal force. To balance that internal force, there is somewhere this normal acting like this, okay, at this place. So now if we take this as the instantaneous the axis of rotation, so in that case the net torque in this direction of the rotation will become 0 and tau net will become 0. Why? Because this normal is anyway that becomes 0 and the gravity is acting like this, and of course gravity is also not impulsive. So for the instant we can apply the conservation of the angular momentum. So tau net about that is 0, so that's why angular momentum just before the collision is equals to angular momentum just after the collision. Okay, just after the collision is equals to just before the collision of system. We are applying for the system first of all, and about which point? About pivoted point. I have told you the reason why about the pivoted point only. Can we apply about any other point? No, we cannot apply about any other point. Okay, so now let's calculate the angular momentum initial. So initially only this m mass is moving with v velocity, right? So initial momentum becomes r vector cross p vector, or otherwise m r vector cross v vector, so m times of x v. This is initial. Finally this rod is rotating and then we have this bullet which is rotating. So I omega, I will be the I system, so that is ml square divided by 3 plus mx square times of omega. So from there this L final becomes, if we take out m by 3 common, so then it is L square plus 3x square times of omega. And now we can equate both of these. The L final equals to L initial. Okay, so that is m by 3 times of L square plus x square 3x square omega is equals to mxv. And now we can just cancel out and we can find out the omega. Quite easy part, right? So it becomes 3xv divided by L square plus 3x square. So this is the omega in general. Okay, so our first answer is correct. Now the problem is we need to calculate where will be the maximum angular momentum, where should this bullet collide or hit so that the angular momentum or angular velocity is maximum, and what is the value of maximum angular velocity. We need to verify these two options as well. So how do we calculate the maxima of this angular velocity? We got a function of this angular velocity in the terms of x, and x is the distance where it is hitting. So what I can do is I can just find out, okay, I have this function omega x which is equal to 3xv divided by L square plus 3x square. Now what I am doing is I am calculating the maxima, and I know what is the process to calculate maxima. I will just differentiate it, the function, equate it to 0, and if the double differentiation for that particular value of x comes out to be lesser than 0, then that x value is the maximum, right? This is like we cover in this our calculus. So d omega divided by dx, if we calculate, so then this is the differentiation. We need to do this differentiation, 3xv divided by L square plus 3x square. Okay, and from here if I proceed and if I just find out d omega by dx, so then the d omega by dx becomes, so numerator differentiation which is 3v, and we'll multiply it with the L square plus 3x square, and then minus 3xv, and the denominator differentiation which is 6x, and divided by L square plus 3x square, and now you equate it to 0. So then if you can just take out 3v common, so then we'll have L square plus 3x square, and the 3v is gone that side, so that's why minus 6x square is equal to 0. So 3v is anyway gone that side, so then we'll have 3x square minus 3x square plus L square equals to 0. So basically 3x square equals to L square, and the x is equals to plus minus L divided by root 3. Of course we know that we are going to take the positive value, so that's why this is the place where we'll have the maximum angular velocity after collision. Okay, now we can also verify, if you wish, you can just differentiate, double differentiate, and you can verify whether it will give the maximum or not. So it means this option is also correct, this one. Okay, all right. Now we need to also find out the omega maximum value. So we got the omega function, and now we can just substitute the xm value. So we had this function 3xv divided by L square plus 3x square, right? We had like this. Okay, now we can just place the value, so that is 3 times of L divided by root 3 v divided by L square, and this will become 3 times of L square divided by 3. So then it is root 3 LV divided by 2 L square, which can be simplified like this. This is the omega maximum. It is root 3 V divided by 2L. So this is the maximum value of the omega which we can achieve. So the fourth option is also correct. Okay, yeah. So this is the solution for this question. I hope you must have understood this, and there are a lot of other questions which I have solved based on the JEE Advanced. You can just look at the videos which are available on the channel. You can just go through the playlist. Maybe I will make the archives playlist, so you can go through those playlists. And if you have the conceptual doubts, I have also made the concept video, a small concept video. They are focused on just clearing the concept. I have not made the like long 1 hour 2 hour lectures. I'm just making the short videos on the concept, so that like you have a conceptual doubt, you can immediately clarify those doubts particularly related to that concept. And of course there will be some JEE mains question as well. If you just want to go through the JEE mains question, you can just go through the JEE mains questions, and still you have some doubts related to like why this concept I have applied or why not the other, I could have done it like this, I have solved it like this, whether it is correct or not, all those things you can explain in the comments and let me know. I will also think and I will also get to learn many things from you. And if you liked really this my channel and my efforts, you can share this with your friends. And let's meet in the next video. Hope your preparations are going well. Thank you.